Well, good afternoon, ladies and gentlemen. I'm David Wong. I run the Technology and Innovation Portfolio at the Society of Motor Manufacturers and Traders in the UK, which is the UK automotive industry trade body. I suppose in Germany, the equivalent is the VAUDEA. I'm glad to be here with you. And I must say that Tom actually raised the bar significantly, but I'm not even going to try. I'm not even going to go there. But I have with me here an illustrious panel. At the far end there is Johannes Springer, whom we heard from this morning, of Deutsche Telekom T-Systems. And we have Michael Falgren, chair of the Automotive Working Group of 5G PPP. We have Thomas DVL of Continental, as well as Ian Macbeth from Transport for London. So I'm going to shut up in just a minute, but what I'm going to do is just very quickly introduce the session. We're going to talk about 5G. I'm very mindful that the session before this, we talk about beyond 5G, and now we're actually pulling everybody back one step before that, which is basically going back to 5G and looking at rolling out a network for true connectivity and exploring some of the key issues. We're certainly very familiar with these, even in the UK, because the UK government, for example, have just actually earmarked £740 million for full fiber broadband rolled out, as well as 5G test beds and trials, which underlines the sort of anticipation of the opportunities that 5G can provide to the entire economy. And we're talking about a subset of the economy, which is basically automotive. And if we're going to expand it a little bit into the Internet of Things, then truly we're going to explore what are the opportunities that can be tapped into by automotive in collaboration with other verticals. So without further ado, as I promised, I'm going to shut up now and I'm going to turn the session over to some of my panelists. What I'm going to do is that I suggest each of the panelists should take just about maybe 30 seconds to introduce themselves, and then maybe put across 2 or 3 points related to this topic before we dive into some discussion. Can we perhaps start with Thomas?
So my name is Thomas de Vial, and I'm working for Continental for 20 years now, previously Siemens. I'm product manager for telematics in Europe, in charge of all telematics products like telematic control units and intelligent antenna modules that you can find in the cars. Also, I'm in charge of all the digital driving story about all the data that the autonomous driving is sending to the backend and down from the backend.
Thomas, if I may ask you, what do you see as the 2 or 3 main issues related to the rollout of 5G?
First, I think 5G is a bit misleading. You think that there was 2G, 3G, 4G, and 5G is the next. And we think that maybe this is the evolution of the telecommunication standard. But it's more than that. It's really a disruptive technology. It will bring new ecosystems. Before, the telematic control unit was connected kind of point to point to the network. With 5G, we will be connected to all kinds of different new ecosystems, like Internet of Things, like connecting the car to the passengers, to the pedestrians, and so on and so on. So the number and the kind of connections will be very, very different. So it means that from the point-to-point telecommunication ecosystem, we will go to kind of point to everything, point to multi-point. It will be very disruptive. Maybe the second point is about autonomous driving. So what's new with 5G? We all know that autonomous driving will be able to work without network, obviously, when there is no network coverage. The car will be able to drive for quite a while. But there is a risk that the car will do minimum risks maneuvers, meaning he has poor visibility, okay, he will reduce speeds and so on. By sharing the sensors with the surrounding cars, you will increase the experience of the because you will be able to drive faster or more with more safety. So 5G will really be enable a new user experience, and it will create a better customer adoption. And maybe last point would be that the cars are evolving to a kind of computer hardware with a lot of software. It's in the past, the cars were like hardware and software were fixed at the production and sometimes some small updates. This is no longer possible because the ecosystems are connected. You are connected to the consumer world, so you need to to evolve yourself. It will be a must for the cars. And 5G is, so the way it's very important also for the time to market. If you want to have a time to market, you need to do things by software. And 5G will be like we know that all the 5G capability will not use at the beginning. It's only after a while that we will be using this. And this 5G network, we don't know already all the use cases that will make use of all its capacity. So it's interesting because it means that the 5G network will not be the blocking point for evolution of the car.
Well, thank you, Thomas. I mean, that's an interesting point that you made about ecosystems, as well as the other point about the potential use cases. So if I could very quickly then jump to Johannes first. I was just wondering whether you could just very quickly introduce yourself to those who perhaps did not witness your session this morning, and also say anything about any potential new features on the back of the remark about ecosystems.
Yeah, Johannes Springer, I'm responsible for the 5G automotive program within Deutsche Telekom Group, and I want to make it very short. So on the one hand, 5G will bring a new radio, and that is a traditional definition of 2G, 3G, 4G, 5G. So that's an evolution of new radio. What will bring this new radio? Of course, it will bring new bandwidth, increased bandwidth, but only with a very limited bandwidth increase. Because we have right now LTE, and what stands LTE for? It's a long-term evolution. So we already improving LTE continuously in our standardization processes. So we have now LTE A Advanced, LTE Advanced Pro, and so on. So this brings a lot of new bandwidth on the radio side, and there will be not that much increase on the radio side for the 5G. So the 5G, and I completely agree with you, the 5G is not that important on the radio side. But the 5G is much more important on the network side. And the network side has nothing to do with the radio itself. It's still evolving within an LTE network. And if we are talking about network slicing for quality of service, for ensuring quality of service, what we have seen in the previous discussion or in the previous presentation, quality of service is key. If we have an emergency case, if you have sports events, if you have these kind of, let's say, overloads today in the networks, we will afford or we will deal with these kind of situations in the upcoming network infrastructure to achieve quality of service for an autonomous car or for safety services and so on. So what will happen within the network is much more important than what will happen on the radio side. So the quality of service or edge computing, direct communication mode, vehicle to vehicle, vehicle to infrastructure communication, positioning enhancements and positioning, increasing the positioning accuracy, the whole Cat-M to increase the coverage situation, even in a garage where there's no satellite site, to achieve coverage. All this kind of stuff is very important that we are not making judgments about the mobile network from today's existing network behavior. It will significantly and drastically change as you have said, a change as a game changer for a variety of business cases and use cases in the very near future. And it has already begun. Yeah.
No, just very quickly on that point, and to also pick up from what Tom of Kymeta mentioned just now, using the Greenville case study, would 5G be able to overcome that sort of capacity constraints?
Yes, of course. It has to overcome the capacity constraints for certain use cases. Because if we are talking about safety, for instance, a safety use case in the car automotive industry, this safety use cases needs the bandwidth and has to get the bandwidth which is needed for that certain period of time. If we take, in contrary for that, a use case for software update for a control unit of a gigabyte, for instance, yeah? This gigabyte software download has not to be made immediately at a certain point in time, at a certain location. No, you can wait 2 hours, 3 hours, maybe until the night, where the software update can be done, as everybody is doing by ourselves. We are uploading and updating our apps during the night when our smartphone is, let's say, sleeping. And that is the way the networks of the future will behave, and we can use these kind of capabilities in the future.
Ian, can I ask you to introduce yourself and make a few quick remarks?
Good afternoon, everybody. It's great to be here. And you've all actually managed to stay around and come and see us. I'm Ian Macbeth. I work for Transport for London. I'm still getting my head around my new job title because my director has decided I'm now going to be head of foresight at TfL. And I kind of think that's probably better than hindsight, but it's quite an interesting challenge going forward. So what do we do in the Innovation Directorate? Well, I'm in charge of our strategic relationships with the automotive industry, working with OEMs on a global basis. In particular, we're in charge of all the trials that Transport for London are involved with on level 4 autonomous cars, and some government funding, we're involved in that as well. There's a bunch of other stuff, and a lot of the buzzwords we've heard today, we go as far as drones and things like that, which are also arguably connected and autonomous vehicles of the future. Safety is absolutely critical. It's embedded within our organisation. We're a public transport authority, which most of you know. We're known for buses, we're known for the tube trains and stuff. But we're also a highways operator, traffic management. We're a regulator. We have a few trials and tribulations going on with the taxi service at the moment. And we're also a planning authority. But it's been really interesting today with all the buzzwords we've heard about connectivity, autonomy, big data and things like that. We haven't really heard very much about traffic management. And fundamentally, what do all these vehicles require is a road. And those are our assets, and that's what we run. So it's really interesting about how safety is going to be incorporated into this going forward. Now, I have a little story. Safety is really key. We do a lot of road safety work with young adults, and we run forums about how we can educate them going forward. And one of the moderating sessions we had was, how do we stop kids having accidents looking at social media? A lot of crashes. And it's not just in London, this is a global phenomenon. So we're saying, oh, well, how do we stop the mobile phone being used in the vehicle? All those kind of things. Lots of hand-wringing about people of my age. And then we asked the kids, and they said, well, we don't want to stop using our mobile phones. We don't want to stop using mobile media. Why don't you design cars that work for us so that we can carry on our lives? And that was a really important part, because it kind of shows you that social media and connectivity is part of the customer experience going forward. It's what the customer expectation is. So that changes the whole view of how we look at connected vehicles. Now, in terms of that, if the consumer is willing to pay for connectivity, that really does kind of point to a use case going forward. And for a public authority, who pays for that network, that infrastructure? Like many public authorities around the world, we don't have a great deal of money, and we have to be very careful with that money. And technological obsolescence is right at the top of our list of things we're going to be very nervous about investing in. So if somebody else will invest in infrastructure for us that can be used for a multitude of use cases, that sounds an attractive proposition. If we can piggyback systems and get data from that, rather than investing in a system that maybe we don't get data back from, that maybe becomes obsolete overnight, and certainly within the time limitations of public procurement, that's a really key point for us going forward.
Who pays? That's an interesting question. Let's hold that question for a minute, and we'll come back to that. Let's bring Mikael in. Mikael, if you could briefly introduce yourself and then say something about perhaps how you see the traffic safety benefits, particularly, that 5G can bring.
Mm-hmm. Yes. Hello, everyone. My name is Mikael Falgen, and I work at Ericsson. And in this role, I've been also able to step in as 5G PPP automotive working group and leading that work. And also I'm a project manager of one of those projects within European Union, which is called 5G Car. I also agree that traffic safety is one of the sort of good enablers that we are sort of building a foundation from here. As mentioned, sort of the one challenge is, of course, sort of the business aspects. Who is willing to pay in the end sort of for this service? I believe that everybody in the room is willing to pay a small amount to cover it, but of course it's still sort of in an early stage of defining which business models and so on that will be the one that will be used. I think it's also interesting to think about sort of the system as such. We want to build up a system and then enable safety, but if we think about sort of statistical deaths compared to a system which at some occasions at least sort of maybe injure someone quite substantially compared to if we did not have the system, maybe just that accident would not have occurred. So in terms of sort of to the general population, how good do the system need to be before we sort of can trust it? Is it so that we don't accept any failure at all, meaning no one can get injured? Or is it still possible that the system is allowed to have some defaults, but still sort of on a statistical perspective provide a much safer situation than what we have today? Because, I mean, currently several people are injured and so on in traffic.
So all very, very good and valid points, and particularly notwithstanding what Johannes mentioned just now, I'm inclined to probe a little bit deeper and ask our panelists, really, if you look at LTE today, a lot can be done. And this is basically assuming we're talking about V2N, vehicle to networks. A lot can be done, and of course there's also the development of LTE, LTE-V for short range. Assuming we have decent coverage, okay, and excellent backhaul, so good throughput, excellent backhaul, and then you bring 5G in, and you put LTE and 5G side by side, and you compare the two. I'm inclined to ask, what are the genuine additionalities that 5G can actually offer to automotive in a way that LTE cannot?
Today, if we have data transmission in LTE, in our LTE networks, we cannot differentiate an emergency call transported via a data channel from a YouTube data transmission which is made by a customer aside. So with 5G, we are able to differentiate different services in different logical networks to make sure that we achieve quality of service for those services which need the quality of service from those services which can live, let's say, with an affordable quality of service. 1 point. Second point, with 5G, we get computing power directly in our networks so that applications can be operated. Of course, we as a network operator, providing only the operational infrastructure, but the operation of the application will be most likely done by another party, maybe by Ericsson or maybe by Conti or whoever. So we are providing computing power so that applications can be operated within our network, within our network structure, to achieve low latency and to achieve, again, an increased availability of a service. Second example. Third example is we will deliver in our networks correction models which increases the position accuracy significantly of a car or of every kind of device which uses such kind of a service to achieve a very low position accuracy in a, let's say, sub-centimeter accuracy range, so that the device can be positioned with an accuracy of 10 to 20 centimeters.
And you think LTE cannot do that?
LTE cannot do that. Of course, we could do it within an LTE network, but as long as we are developing that within our networks, it's instantly a 5G feature. Because, you know, from the 3GPP world, where I'm coming from, everything which is from release 16 standardization on in the 3GPP world is about 5G. Wherever it is related on LTE or based on LTE, it's still 5G. So, you know, it's a little bit a definition problem. So if the standardization process of release 16 and the following is all about 5G, everything which is standardized from release 16 on is 5G. And whether it's edge computing stuff, which can be done, of course, with an LTE radio, whether it's a slicing stuff, whether it's a precise positioning, everything is 5G. And these are new network capabilities which have nothing to do with a new radio, which is maybe the very slim and very sharp definition of 5G, but which is not sufficient, as you have said. I fully agree.
Do other panelists agree, or have you got anything else to add before I move on to the next question? Well, let me turn around and ask the other panelists another question. I promised I was going to come back to the question of who pays. So it's a monetization question, a $1 million question, probably even $1 billion question. And we talk about 5G versus what people in traffic management would basically suggest ITS G5, 802.11p, or if we are across the pond, we'll call it DSRC. If we talk about ITS G5, we are basically talking about an ecosystem with the traditional players, traffic management players, road authorities, typically. But we talk about 5G, a network of networks, and potentially we are bringing in new players and new verticals and looking at the vehicle as a platform, a genuine Internet of Things solution. But of course, when we cross verticals, and there are a couple of implications, data flowing across verticals will bring cybersecurity implications, but also monetization. I think the monetization question is an interesting one. We may not have the answers today, but I'll be genuinely interested to hear your views on how can actually 5G and the services with the data that flows across verticals be monetized. Anyone would be keen to?
Okay, so as a public authority, we have to be technology agnostic. So whether or not it's SAT, 5G, or G5, we will look at all of those things. But I can't help making an observation about consumer behavior. We're an organization that lives and dies by our customer offer. Safety is part of that, I've mentioned. You can't help noticing that people are on their mobile devices all the time. Those devices may change to wearables in the future, but they're addicted to them. You know, we have problems with people looking at mobile phones at gate lines. We have pedestrians stopping in the middle of the road and getting run over and hit because they're not paying attention to stuff. So people really value connectivity. I couldn't help seeing a statistic about how long it took to download a high-definition movie. Not that they existed back in the day, but Guardians of the Universe would take you about a day to download under a 3G network. Under a 5G network, it'd be seconds. Now, can you imagine any member of the public, a consumer, who is used to having that download speed in a domestic or workplace environment, settling for any less in a connected autonomous vehicle? I don't think so, because that will be a second-rate experience. So I think that is where the business case stems from. Public acceptance about the services you provide in the vehicle and how quickly you can do that and how reliably you do that. And yes, a safety case is great in there because you can slice for other things and ensure bandwidth is in place. But I think that's really, really key. And in terms of who pays for that infrastructure, this will be shared across a connected city. It's not just automotive we're talking about here. It's health, it's energy, it's business. There's a whole bunch of things that will be using this connected platform. And therefore, although you might not like to hear this in an automotive conference, automotive is just part of a much, much wider cityscape. And in those circumstances, the use case and the business case is amortized over a much broader spectrum than just automotive.
So in a nutshell, mainly data-hungry services that consumers would pay for. And in this case, an example would be infotainment services.
Absolutely.
Sure.
But, you know, we use apps and stuff like that. We didn't invent a new technology to deliver apps to our customers. We used what people were using already. And it's quite interesting, traffic management services don't have that capability other than maybe pinging a message into a vehicle that nobody actually really takes much attention of. So it's quite interesting, what sort of technology is the consumer willing to use?
Sure. Let me quickly bring Thomas and Mikael in. Have you got any thoughts about monetization?
So maybe first, I think it's important to mention that ITS, the ITS band in Europe, 5.9 GHz, is a free spectrum. And you know that at 5GA, we are promoting that the cellular V2X is using a free spectrum. It will be important for the business case at the end. And at 5GA, there is a special working group 5, I think, in charge of defining also what are the business case for all this V2X story. And then we need to bring all the benefits and to monetize the benefits in a nutshell.
Mika?
Yes, I agree with sort of previous speakers, and I also think sort of the infotainment is, as an end user, more obvious sort of that you are receiving the service compared to the traffic safety applications. We're sort of protecting everyone, also the ones not having a vehicle, sort of the pedestrians walking around and so on. So I think, I mean, as an initial step, I think the infotainment services will be sort of the driver in terms of the business. But then, when sort of the overall system becomes more clear, one can then also start driving the traffic safety business models. I believe, because currently it's a bit, at least for me, unclear where are the different dominating parts. I mean, the vehicles themselves, of course, are getting more and more clever, keeping track of things, and if the other parts are not there, they of course don't want to collide. So that system itself should be stable and good. And then we have this short-range communication. How much can one benefit from that? And then adding on top the cellular system, connecting even further, longer ranges communication, and then satellites, sort of as we heard about in the speech before here.
Thank you. Annie, do we have time to bring the audience in by having just one quick question on Slido?
Well, there were two questions. If you can do rapid fire, then we can do one of them. Would you mind bringing up Slido? So 5G
is great. The 4G coverage is less than 70% in Germany. Wait till I tell you what's the coverage rate in the UK. 5% of geography in UK is not about 2G. It's all 5G automotive business only happening downtown and on highways. Perhaps a quick answer, if there's one taker of the question.
I think that's for me. Now, if you hopefully are in a Deutsche Telekom network, 5G coverage is right now over 90% in Germany. 90% of the population, that is important to notice. So the major highways, Autobahn network is covered by 4G. That number of 70% is not right. And of course, we are continuously investing into extending our network coverage. But we have to make sure that there is, for every party also a business case. We will only invest in those regions and in those areas where there is traffic. And if there is only a very limited amount of traffic, there is no rationale to invest unless the regulators would make a rule and regulation that for a 4G or 5G license, the mobile network operators have to make sure, have to take care about sufficient coverage. And most likely, they will do also with a 4G, 5G, as they did already with a 4G. So that is maybe for the first point. Yeah.
Is that all the time you have?
Yeah, I'm sorry.
All right. Thank you.
Thank you very much, though. It was very interesting.